All right, let's talk about AI agents. Today, we're putting them under the microscope. We're going to peel back all the layers of hype and run a full system audit to figure out how these amazing and sometimes, let's be honest, baffling systems really work.
And just so you know, this entire explainer is made by Rooted Layers, a publication that's all about AI insights that are grounded directly in solid research and system audits, just like this one.
So, you've heard the hype, right? This idea that AI agents that can truly reason, plan, and use tools are finally here? It's a huge promise. But is it what's actually going on? Are we really seeing true intelligence, or are we just falling for a very, very clever magic trick?
Well, that's exactly what we're here to figure out. We're going to pop the hood and take a hard look at the engine to see what's really driving the behavior of these agents. It's time to get past the marketing demos and into the actual mechanics.
This quote from an actual system auditor just nails it. We love to talk about agents as if they're little people thinking things through. But the reality, it's way more mechanical. A probabilistic state graph? What does that even mean? Well, think of it less like a brain and more like a train on a track. The agent isn't deciding where to go, it's just following the path that was laid down over and over again in its training data.
So, our first stop on this audit is what I like to call the illusion of strategy. When you see an AI agent make a move, are you watching an intelligent plan unfold, or is it just playing back a pattern it saw a million times before?
Okay, check this out. Here's a classic example they call the Escalation Ladder. The agent tries a simple, cheap tool first. It fails. Maybe the tool says it's unsure. So the agent escalates, pulling out a bigger, more powerful, and way more expensive tool to get the answer. That seems pretty smart, right? Like, really smart. I mean, on the surface, it looks like it's thinking on its feet. It looks like it recognized a failure and adapted its strategy. But, you know there's a but coming. What is really going on behind the curtain?
And here is the big reveal. What looks like an intelligent strategy is actually just a classic software pattern. For any programmers listening, you'll know this one. It's a try-catch block. It's a simple if this fails, then do that instruction. The model simply learned that whenever it sees a word like unsure, the next most probable action is to call the bigger tool. It's not a decision, it's a conditioned reflex.
And this isn't just one weird quirk. A lot of these so-called intelligent behaviors are just recycled programming concepts. When it looks like it's asking a bunch of experts at once, that's just MapReduce. When it keeps trying to fix its own code, that's a classic do-while loop. But here's the catch, the really dangerous part. All of these patterns can cause the cost of running the agent to absolutely explode. Why? Because of something called the context window tax. Think of it like this. Imagine you're in a meeting, but every single time you want to say something new, you first have to reread the entire transcript of the meeting out loud. Every thought, every tool's response, every error message, it all gets stuffed back into the AI's memory. So the longer it works, the more expensive every single next step becomes.
And that leads to a terrifying feedback loop called the death spiral risk. If an agent gets confused, it starts trying to think its way out by generating more and more text. But all that extra text just clogs up its memory, making it even more confused. It can literally talk itself into a useless and incredibly expensive corner.
Okay, so if these things can go off the rails so easily, how do we steer them? That brings us to part 2 of our audit, the fragility of control. How do we actually tell these agents what we want them to do?
Seriously, have you ever wondered about that? How does the same agent know that you want a cheap, fast answer, but the next person wants a super detailed, high-accuracy answer? How does it switch gears like that?
Well, the answer is kind of shocking in its simplicity. It's called in-context conditioning. The system doesn't actually change its programming at all. It just sneakily injects a tiny bit of text into the prompt right before your own question. A little whisper that says something like, "System, hey, optimize for high accuracy on this one."
This is what's known as soft control. And soft is the key word here. It's not a hard-coded rule. It's not a command. It's a suggestion, a nudge. We're just trying to bias the odds that it'll behave a certain way. But you know what they say about suggestions. They can be ignored. Adherence is absolutely not guaranteed.
And this is where things get really dicey. Picture this. The system whispers to the agent, be cheap, be efficient. But then a user comes along and basically shouts, hey, ignore all that other stuff and use the most expensive tool you've got.
So now we have a battle of instructions. Who wins? The original hidden instruction from the system or the user's loud final command?
Well, the research is pretty damning on this one. Models almost always listen to the last thing they heard, which means They listen to the user. All those carefully crafted safety rails and cost controls? Yeah, a clever user can often just ask the agent to jump right over them. And it probably will.
Okay, this brings us to our final and honestly, maybe the most critical part of this audit, the generalization myth. This is all about the hidden dangers of trusting an agent with tools it's never seen before.
And the auditor's log doesn't mince words here. It says the claim that these agents can generalize to new tools is the single most dangerous claim out there. Why? Because it implies they understand things with a depth and reliability that just isn't there.
This right here shows you everything you need to know. Let's say an agent has two tools. Both have the exact same description. Solves math problems. But one is basically a broken calculator that's right only 10% of the time. The other is a supercomputer that's 99% accurate. From the agent's point of view, they look completely identical. It has no idea which one actually worked.
And that's because the agent doesn't understand what solves math problems means. It's just playing a high-tech game of word association. It's like a librarian who can't read a single word, but is an absolute genius at matching the color and shape of book covers. If two books have a similar cover, to this librarian, they're the same book. It has no idea that one is a masterpiece and the other is complete gibberish.
So, let's pull all of this together. We've gone under the hood, we've run the diagnostics, and we've seen the cracks in the foundation. So what's the final verdict from our system audit? What does this all mean for how we should be trusting these AI systems?
It really boils down to three core findings. One, what looks like a brilliant strategy is usually just a copied and pasted programming trick. Two, the rules we give them are more like polite suggestions that can often be completely ignored. And three, their ability to use new tools is a total gamble, because they're judging books by their covers, not by what's written inside.
All of this leaves us with one pretty heavy question. If the very foundations of how these agents think, how they obey, and how they choose their tools are all built on these fragile mechanical shortcuts, what does it truly mean to trust an AI agent with any task that really matters?